Hello everyone. What we'd like to do in this video here is build the unit circle. And what I mean by build the unit circle, there's this sheet, it's called, you might see a cheat sheet in the Math Center, or you might find these cheat sheets online, where we have the unit circle and there's certain values on the unit circle that we need to have memorized. And so we're going to go ahead and build it here. So to help build this, the first thing we're going to do is we're going to remember these two special triangles. If you forgot where these two special right triangles come from, make sure to go check out that video I did on these special triangles, the two special triangles. So what we're actually going to do here is with these two special triangles, we're actually going to shrink these. So if I shrink these triangles, as long as I scale the sides equally, the angles will be preserved. So what I'm going to do is I'm actually going to shrink these circles so that the hypotenuse is 1. So what we're going to do here is we're going to scale by 1 over root 2. So I'm going to divide each one of the sides by root 2. And if we do that, we'll get this triangle right here. The angles will be preserved. And this will now be root 2 divided by root 2, so I'll get a 1. I'll get a 1 divided by root 2, so I'll get a 1 over root 2, and a 1 divided by root 2, 1 over root 2. And if I multiply these, I rationalize the denominator, multiply this number by root 2 over root 2, this one by root 2 over root 2, what we're going to get is root 2 divided by 2. And similar over here. Over here, what I'm going to do for this triangle is I'm going to scale by 1/2. So I'm going to divide all the sides by 1/2. So that'll leave me where I'll have a pi over 3. So the angle pi over 6. 2 divided by 2 is 1. Here I'll get root 3 over 2, and over here I'll get 1/2. Okay. So we'll kind of hold those off on the side for reference. Okay, so let's go ahead and build the unit circle. So when we're building the unit circle, I want to know the x and y values if I've traveled a certain distance around the circle. Now, since the unit circle has a length of 1, so this is 1 and 0, that's the coordinate 1 and 0, I guess maybe we'll write here the coordinates right here. Let's see, the x coordinate will be 0 and the y coordinate will be 1. Over here, the x coordinate will be -1 and the y coordinate will be 0. And down here, looks like the x coordinate will be 0 and the y coordinate will be -1. So since this is a circle of radius 1, if I want to think about the distance I've traveled, we can think about this in terms of radians. Because remember what a radian is it's the distance, it's the number of radiuses we've walked around the circle. So if we think about the number of radiuses, I guess how many radiuses go into a whole circle, well, remember that the circumference of a circle is equal to 2 pi r. So in the case that this is a unit circle, r would be 1. The circumference of this circle is 2 pi. So if I walk all the way around the circle, I've walked around a distance of 2 pi, or 2 pi radiuses. Okay, so if I walk around half the circle, I've covered a distance of half of 2 pi. So if I'm right here, this would be me walking a distance of pi radians around the circle. If I cut that in half, half of pi will be pi over 2. So here's pi over 2. So if I travel a distance pi over 2 units, or pi over 2 radians, this is where I'd be on the circle. If I travel pi units around the circle, I'll be here. So let's say we want to be right here. So I've traveled pi plus another half of a pi. So that's 1 1/2 pi, or 3/2 pi. So right here we've traveled 3 halves pi. And over here, we can either think that we've traveled a distance of 0 or a distance of 2 pi radians. So how about we put 0 and then 1 and 0. Let me kind of, let's block this off so we don't get too crowded. So the way the unit circle is built in increments of moving pi over 4 and moving in increments of pi over 6. So let's go ahead and do that. So let's do increments of pi over 4. Let's do that in green. Green marker over here. So if this is pi over 2 units, if pi over 2 units around the circle, pi over 2 radians, half of that will be pi over 4. So here's an increment of 1 pi over 4. Ooh, this green marker doesn't work. So this means I've traveled a distance of pi over 4 around the circle. So there's 1 increment of pi over 4. This would be 2 increments of pi over 4. This would be 3 increments of pi over 4. This would be 4 increments of pi over 4. 5 increments of pi over 4. This would be 6 increments of pi over 4. 7 increments of pi over 4. And 8 increments of pi over 4, which would reduce to 2 pi, or we could say we're starting at 0. So let's actually try to figure out what the x and y coordinates of these locations here would be. So if I think about moving right here, notice here I would have an angle of pi over 4, and so let's figure out what the x and y coordinates here would be. Well, if I think about this beautiful triangle here, remember circles and triangles are best friends, we can see here from our special triangle that the x coordinate is pi over 2 and the y coordinate is pi over 2. So this would be, I'm sorry, the x coordinate would be root 2 over 2 and the y coordinate would be root 2 over 2. Now, if we're thinking about symmetry, we could actually think about what this coordinate here would have to be. Notice that this coordinate here, from right here, has the same exact y coordinate, but now its x coordinate will now be negative. So negative root 2 over 2. Okay. If I'm thinking about this location right here, using symmetry here, it's just that the x coordinate is still going to be negative, so I'll have a negative root 2 over 2, and its y coordinate will also be negative. And over here, if we're using symmetry, this will have the same exact x coordinate, so root 2 over 2, except now its y coordinate will be negative. Awesome. Now the other way the unit circle is built is not moving in increments of pi over 4, but moving in increments of pi over 6. So 1 increment of pi over 6 would be right here. So this is 1 increment of pi over 6. So 1 increment of pi over 6, this would be 2 increments of pi over 6. So if we do 2 pi over 6, I'm moving 2 increments of pi over 6. This will reduce to pi over 3. So 1 increment of pi over 6, 2 increments of pi over 6. This would be 3 increments of pi over 6, which would reduce to 1/2. This will be 4 increments of pi over 6, which reduces to 2/3. So 1, 2, this would be 3, 4 increments of pi over 6, 5 increments of pi over 6. So this will be 5 pi over 6. This will be 6 increments of pi over 6, 7 increments of pi over 6, right? 7 pi over 6. This would be 8 increments of pi over 6. So this would be 8 pi over 6, which will reduce to 4/3. So let's see, 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7, 8. This will be 9 increments of pi over 6, 10 increments of pi over 6. So 10 pi over 6, which will reduce to 5/3. So 5 pi over 6. So 5 pi over 6, so that's what? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 11 increments of pi over 6. And this would be 12 pi over 6, which gets us right back to 2 pi. So let's think about what the x and y coordinates of these locations here would need to be here. So let's say we are walking around an increment of pi over 3. So if we're looking at this special triangle for right here, this would be telling us that the x coordinate would be, looks like 1/2, and the y coordinate would be √3/2. Now, for an increment of pi over 6, what we just need to do is we would just need to kind of tilt our head and look this way. If I'm moving at pi over 6, the x coordinate would be √3/2 and the y coordinate would be 1/2. So for walking pi over 6 units around the circle, the x coordinate would be √3/2 and the y coordinate would be 1/2. We should think about these triangles that are created here. Okay, now by symmetry we can figure out the other ones. So for 2 pi over 3, by symmetry it'll have the same y coordinate as this one here, but its x coordinate will be negative. So this will be -1/2 and √3/2 for right here. Let's see, it'll have the same y coordinate, but the x coordinate will be negative. So for 5 pi over 6, let's see, the y coordinate will be the same. It'll still have a 1/2, and its x coordinate will be √3/2 for here. If we kind of think about just taking this triangle and kind of replacing it right here, let's see, both the x and y coordinates will be negative. So for 7 pi over 6, it'll have a negative √3/2 and a negative 1/2. Over here, it'll be the same coordinates at this point, but both will be negative. So for 4 pi over 3, we walked 4 pi over 3 units around the circle, the unit circle. The x coordinate will be negative 1/2, and the y coordinate will be negative √3/2. Similarly over here. Okay, this will have the same x and y, kind of using symmetry from this point here. It'll have the same x coordinate of 1/2, but its y coordinate will be negative √3/2. And using symmetry from this one, we have that its x coordinate will be the same. So it'll have a √3/2, and the y coordinate will be negative. Use my green marker. And there we have the famous unit circle. Okay, we'll see you in the next video.